Hi, welcome to NimConf 2026, and this is 3 Code, the economical coding agent. I'm Carlo, and this talk is going to have two parts. The first is just I'm going to tell the story about how I came to do something as somewhat insane as building my own coding agent. And number two is we're going to look at 3 Code and do a little bit of AI assisted coding with it. And I'm going to talk about the design and a little bit about the development. Thank you very much for being here. I'm really excited to be here. Thank you for listening. Let's go. What is 3 Code? 3 Code is a command line program that helps you write code using artificial intelligence, language models. Um, and what happened was, like, why I went out and made my own coding agent is because, well, the situation was I already was writing a lot of my own tools in NIM because usually they end up faster. They turn out exactly how I like them. I have like my own ideas about what makes a good program. And one of those ideas is I like programs to be economical. And what do I mean by that? It's not exactly the same thing as minimalism. Like a minimalist program does as little as possible, and it will show you as little as possible. And it doesn't mind sacrificing features to be tiny and small. But economical is different. Economical has a stated purpose, in this case, to help you write code. And it can be fairly full featured. But in order to achieve its goal, it's going to do as little as possible, right? Um, so, for example, 3 Code, it has quite a bit of tools that it provides to the language model, more than some other agents. But I think all those tools are pretty important in order to do a good job. And then it saves tokens down the line, right? So it's a different trade-off. Minimal just wants to be small and have a very little or take little time to learn, I guess. While economical wants to be like tiny within the context of its defined purpose. So it's not this. So it's a different trade-off, a different kind of trade-off. And so I like NIM because it's so economical, right? Like it doesn't use a lot of my brain cycles to get stuff done because it's expressive, and it compiles to fast code. So like in different dimensions, it does less. It does more with less. Um, and 3 Code is like that too, you know. So because it's written in NIM, it gets all this computer resource economy for free, right? At least on your computer. It's a couple of megabytes, and the other agents are all like, you know, at least a few hundred or more, even though they're command line tools. And uh, uh, so let's see. I was writing my own tools a lot, you know, and then the AI revolution came along, and I tried it, and after a while, I realized, whoa, this thing is writing some pretty good NIM code, like the existing tools were, right? This is really good NIM code. I probably shouldn't ignore this anymore, you know. And then most of the my program my reference programmers, like people I respect for their work, started using it, and so a lot of indicators said I should probably jump on, and I did. And in a week, I finished all my side projects. They were feature complete, and I was like, wow, okay, I really shouldn't ignore this. And so uh, I started using it and a lot, and it worked great. I loved it, and suddenly the AI token squeeze hit. The tool I was using just really throttled down how much you could do with it for like whatever plan you were on. And like that really hammered home the point of how much vulnerability the trade was. Like you use AI to code and you're so much faster, but suddenly your lifeline is to a single company in the worst case, you know. And I was like, uh-oh. Like I knew that this was the trade-off, but I didn't think it would happen so fast. I thought I would have more time to adapt, you know. But no, you know, from one day to the next, I went from like super productive to can't work at all, right? And I was like, oh, okay, yeah, here it comes. This is just as experimental as you would think it is, right? And so I went looking around for some open source coding agents, and I ran into the same issues that I had with other tools. You know, like they were too big, or in some cases the tools would splurge tokens. They would use much more tokens than the provider's own tools. And I was like, wow, okay. You know, these guys aren't optimizing at all for token use, or not very much. They have different priorities. And then I found one tool that I liked, and it was just a bit too clunky because it was using a scripting language, you know. And I was like, you know, how hard could it be? It's just a loop and like some API calls. Man, this was hard. It was really hard. And it wasn't that hard because of anything to do with AI at all. It was hard because if you want things to be exactly like you imagined them, Unix terminal programming is fiendishly hard. You know, it's really hard. And well, so so I wrote three code in. Oh yeah, let's finish off this initial part before we jump into three code, into the design. So the reason I wrote three code was simply because I couldn't find anything else I was happy with, and the reason I felt it necessary at all to have like a different agent was simply because since I was now dependent on AI inference in order for my livelihood, in order to be productive in my occupation. I couldn't be dependent on one company or even several companies using the same chips. And then I found out that you could use Chinese models and that they were good enough. And or actually, in case of GLM, pretty darn good. I found that was okay for me. Like at least now, I have two different sets of chips. Like if a group of companies hoards all the NVIDIA chips, well, okay, that's not going to slow down the Chinese companies, you know. So there's like two possible sources to get AI inference, to get good AI inference. And I was like, okay, you know, it's not perfect, but I can live with that. I can depend on that, and it doesn't feel irresponsible. It feels like reasonably okay, you know. But, you know, it's still possible that everything is going to go away, you know. So, you know. But for the time being, that's a pretty good setup. So, let's go and look at three code. It's right here. This is it. It's a command line program. We have the typical bracket where you can type your prompt. This is a prompt where you can tell your program what to do. And there is a bunch of tools. So maybe we'll just do a silly little prompt just to give an overview of the tools. We'll just tell him to run the to-do list tool and create an example list, write an example file, patch it, and read it back. Simple as that. So look here, you can see the live resource usage. This twirly thing means that an API call is ongoing, and the tool calls, they all have a symbol like this one. This is the symbol for the to-do list, and this is like a tool call, and this means that the model tells this coding agent, hey, here's a to-do list I came up with, and please feed it back to me later, and that gives it, that kind of nails it down a little bit so it doesn't go all over the place. The other tool calls that we have here, this is a write, it's a W as a symbol that wrote just in my home directory a file. And speaking of security, I have good backups. 3Code, I'm going to add a sandbox. It doesn't have one, but it has like basic security. Like it'll block like obvious bad commands, like remove everything on the hard drive and stuff like that. But I haven't had to use backups yet, so I mean the model is doing a good enough job not to do like crazy writes. Yeah, but there is a sandbox that I have planned in the works. But for now, I'm perfectly happy with it. I know this is like considered like a bit nuts to like allow writes in your home directory, but I've never had any problems with it. So let's keep going. Here, this is a patch command. It's just changing some stuff. This is like regular patch syntax. And here's a read command. It says, okay, this is unchanged, so we can look up. So this is an optimization to save some tokens. And look, it actually used this tool. It completed everything. It worked. It's showing here. It's this $sign is the symbol for a bash command that the model can run. And that's pretty much it. And this is a text response. So this philosophy of being economical, I tried to make this UI as small as possible, but not smaller, right? So, and it's supposed to be easy to read. I hope I was successful, and I hope you're going to try this out and tell me if I was successful. I'd love to hear from other users. Here's something interesting. Down here, this is a receipt, is what I call it. Like this is showing, like this last API call, how much resources did it consume. So this is the token window, context window, pardon. And it's 2%. That's not very much of it is in use. We had in this call 3,000 input tokens. Of those, 2.9 thousand were cached, so only 100 new tokens, and that means that not so much of the plan allowance, token allowance of the plan was used, and the downloaded token was 166 to do all this. So it's not bad. Now, this is all guesswork, educated guesswork. I haven't done any proper benchmarking yet for 3Code. I've also planned to do that. But all my observations say that it's probably about half to a third of the tokens that 3Code uses for a comparable task than other agents use, is my guess. And it also works for actually writing some code. Let's do that right now. Let's say, okay, great job. Let's restart this. We have the colon as for a system command. Clear this up. And one tool I didn't show you yet is we can actually have the model clear its own session. And we use that for 3Code's particular brand of longer sessions. You know, we don't have any kind of parallelization in 3Code, and that's by design, simply because most of the research in language models say that it doesn't really bring a better result than just doing all your work in one session, in one context. So for this reason, if you want to do something longer, you have the 3Code draw up a plan with one file per step, and have each step clear the context and then pass the next file on to implement, right? So you have a kind of a recursive loop with context clears. And what this does, it basically automates what you do anyway. You know, you hack on this AI-assisted machine, and then when the context gets too big, you create a summary, and then you put that in a file or in the clipboard, and then clear the context manually and continue. And this is how 3Code long sessions work. The exact opposite of most other systems that focus on having a long-standing context. 3Code says that's never going to be economical in the short term, which is 3Code's focus, what works right now. We want to just automate what everybody's doing anyway, you know. So if you have a long plan that you want implemented, like I'd use it mostly for creating a lot of tests for a test suite. And I'll say, okay, give me 10 steps to the plan for each part of the program, each module. And then 10 files are created. And each of them says, okay, implement tests for this section, and then clear the context and run the next file. You know, and it works pretty well. Like it uses much less tokens than creating like a huge monolith of a session to create like a lot of test files for a huge program, you know. So this is how 3Code does things, and it's easier to implement too. And so we also, by design, don't have the MCP protocol, just because it eats a huge amount of context to have those things, right? So we have a lot of features as long as they don't use a lot of resources, and all in all, I think it's really nice to use 3Code. So now let's actually use 3Code to do something. We're going to implement a small command line tool, and we're going to let the model decide which one, and learn something about how to model ticks. About, you know, does it have a derived sense of humor? So we're just going to write down implement a small command line tool that's fun in the Nim programming language. That's it. Go. Okay, so now 3Code is running, and we'll see what it does. I don't know what it's going to choose. Oh, here it says, I'll make a Nim command line tool, a fortune telic magic 8 ball with ASCII art. Okay. Not bad. That's pretty good. I'm curious how it's going to turn out. Okay, we can see. Now it's eating some more tokens than it did before, which was to be expected. Here we're on 3 kilobytes, or 3,000 tokens input, and some of that is the system prompt. We're not going to go into the design of it too much. But yeah, while it's working here to do its Magic 8 Ball program, um, let me tell you about some of the terror. Wait a minute, it's already done. Well, hey, that's nice. That's great stuff. Okay. We're going to run it. It did. Oh, my question. Okay. What is the meaning of life? That's always the first question I ask anything, if I can choose it. Of life. It's thinking. Cannot predict now. Well, okay. What is 2 plus 2? Concentrate and ask again. Okay, so it's just going to give you like some randomishly silly answers, I guess, which is what we wanted, right? So I guess that's an example of a GLM's sense of humor. You get a Magic 8 Ball that's going to answer your questions. Not bad. It's a pretty cool tool. It was pretty fast to code too, so nice job. Oh, let's look at the code. Let's look at what this Magic 8 Ball looks like. Okay, it uses randomize. It has a constant for what the Magic 8 Ball looks like. It has a predefined list of silly answers. It has a little bit of animation logic in there using standard out. And I think that's some fairly decent NIM code right there. You know, it's not bad. Not bad at all. It meets the definition of what I said. And yeah, not bad. We're not going to do anything more complex. I think it would bust the time. But let me tell you about why it was so hard to write 3 code. And so here's how I did it. I just opened up. I started with Claude Code. And I just told it to write a coding agent and just let it do its thing. And what came out was a pretty good, pretty well-working small tool. And I had it write some unit tests, and and then after a while, when I added features, it got slower, and then I needed to constantly tell it what I wanted, and something completely different would come out. And I was like, this is not how this is supposed to work. That was the first wall I hit. And so I just got completely frustrated, and I just said, well, okay, hey, Claude, I want out of the loop. I'm part of the loop. That doesn't work. You have to be part of the loop. And sure enough, Claude came up with an idea to create a simulated terminal view, you know, and have a simulated terminal and run the tests on a simulated terminal so you can have assertions on it. Because what the 3 code tests were doing, they were simply dumping out terminal bytes and then checking out that the right terminal bytes had been dumped out and not checking at all what anything looked like. So it was just all AI guesses, lucky guesses, I gotta say, and it was surprising that it worked as well as it did, you know, to create all this fairly complex terminal stuff, you know. Have a look at 3 code. Look, this here, I call it a fat prompt. All this is regular standard out up here. There's nothing crazy about it, just a little bit of formatting. And this here is part of the prompt. This sticks to this prompt line here, right? And you can't do that with a standard out. You have to use TUI style stuff. But because I didn't want to steal the whole terminal, which would break your terminal history, which is very important in order for a command line tool that's like prompty. So I had to define the prompt as area as having 3 lines, and that needed to be, the location of that needed to be relative to this prompt line right here. And it had to update in multi-threading so the API calls could run in the background and we could see what's happening. And there's one thing I didn't demo here is because I'm not using it right now, is a ticker. Like this third line here would show you all the reasoning that the model does when it does it, which is usually hidden. And then you can, if it's as a ticker, you can just kind of glance at it and you can see if your model is doing something crazy, and you can see that it's still working even if it takes a while. And all those things are pretty complex. Like you have regular standard out, and you have 3 lines that are relative to the prompt line, and then the prompt line isn't necessarily at the bottom. It could be at the top, So that was surprisingly fiddly. And more and more, I was part of the loop. I would make a guess, and then I would tell it if it worked, and that's just soul crushing because you have no control, and you're just part of. Your hands are part of this development loop. It's awful. So I just told Claude, "Hey Claude, dude, I don't want to be part of the loop anymore." And Claude came up with an idea to be able to test its own visual output by programming a sub set of terminal commands and rendering them in Nim, which is pretty advanced when you think about it. It conceived of a solution, and I just stated my problem. I want out of the loop, and Claude came up with that solution. That's really pretty advanced. So that worked, right? The tests stopped looking for the right codes. I stopped testing what was done, and I started testing the result. And after that architecture was set up, I could code again. I could say, "Okay, Claude, now give me whatever feature," and it would work again. And then that was about the time when it was like sort of done. It was 3 code 0.1 or 0.2 or something. It was like, okay, this works pretty good. I'm going to start using 3 code to write 3 code with GLM, and that worked too. It was like, wow, good stuff, I'm almost done. Yeah, right. Then I wanted to be able to type something while 3 code was working, to be more effective, So that's an advanced feature. But it's economical for my brain, So being economical is like, constantly doing all sorts of trade-offs and finding out where the sweet spot is, where within all of the factors that you have access to. And that's my definition of it, at least. And to find like a global sweet spot. And my global sweet spot for 3 code was that I should be able to type while the model is working, and then inject that into the flow. It's a standard feature for other coding tools, but this particular standard feature I thought was important. And I needed to completely rewrite the architecture for that because it's even more multi-threaded then. I have to be merrily typing in my prompt, and at the same time the token ticker is there and updating, and it's pretty dynamic, and all that is relative to the prompt line and not the bottom of the screen and all sorts of stuff. And that's where it went hairy. Nothing worked again. It was in the same place again as before, and I couldn't figure out why, because I had already created a visual terminal, or had overseen the creation of that terminal. And so and then I started running out of tokens on my ZAI plan. And then that's when Codex came up with the token special. So I just threw a lot of tokens at this problem. And the analysis was simply that while the virtual terminal had been created and the AI could see parts of the terminal, most of the tests were still the old tests. And it was so much code, I couldn't go looking for all of that. It was fairly vibey at that point. Like, my plan was always to look at the code when I'm done and then improve it, but not while I'm still exploring. I didn't want to look at too much code, right? So it was like semi-vibey exploratory coding style. And so I was like, okay, it simply wasn't, the transition wasn't complete. So I had to manually tell the model to disable all of the tests, and really in small iterations, now, okay, change all the tests to really actually use this virtual terminal and greatly expand the functionality of the virtual terminal. And now the virtual terminal is fairly complete, and it actually catches frame by frame what is on the screen. Every change is a new frame, and just separated by a few dashes in the file. So it's very, 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 very tight testing. Basically an animated representation of what's on screen. And at that point, the language model started working again because it could see what I see and test by itself. And then if I wanted to change, I could give it a screenshot, a textual screenshot of what was going on, and tell it to change that. And finally, it would do what I wanted again. But boy, in order to find out what it took to get this loop working again and get myself out of that loop, that was just like, it used to be to debug an obscure bug, Only now I was debugging something I didn't even understand, the language model, an even more complex system. So I had a more powerful tool to do all of that, but then I had to debug this more complex process, and that was a huge brain fryer. My goodness. So what's my verdict? I think that AI coding is here to stay, at least to the extent that we can still have it. It's definitely desirable. You can get a lot more stuff done a lot faster. But it's definitely not easier if you really know what you want. If you're not just going to take whatever the model gives you. If you really want to define. And the difficulty of engineering has gone into defining the result in a way that the model can understand. That's the new engineering aspect here. And fiddling with it until you find a way of displaying your requirements to the tool. Yeah. So that was my learning from making free code. And aside of that, it was very feasible to do. I guess it was, I don't know, a week or two of hardcore pulling your hair out. But that was really it. So it wasn't a weekend project at all, but it wasn't months and months and months of coding like something like this would have been before. It was still fast enough to do if you can make some time for it. So yeah, I think it was a success. My original goal of being able to pay for my tokens out of pocket, there's all these providers where you can buy inference from with all sorts of open source models. And I was hoping that I could get free code so economical that I could pay by usage, right? Like every provider gives you two options. You can get a plan with a flat rate, or you can pay by usage. And the plans are all financed by capital expenditure, right? So they're eventually going to go away and become terrible, or go away completely. And from what I hear, like the usage billing is more or less, it at least covers the cost of electricity. So somebody can make a profit like doing that. So I was hoping to get free code so economical that I could do this in a sort of sustainable way, and have it be cheaper than the plans, right? But that didn't work. If you buy GLM by usage, you're probably going to be paying 10 times what the plan would cost you. So I still have to play that little unsustainable game for now, and hope things will work themselves out in the meantime. It's like the true Silicon Valley way of doing things, right? But from, like, I don't have hard data, but from my dog fooding it, like using 3Code to develop 3Code, using 3Code to develop all sorts of stuff, it's a world-class system. It can use the best models. It works well with those models. I think it provides the right amount of tools so those models have a little bit of structure. I think it's a world-class coding agent. I think it works. I think it's it can it doesn't have to hide behind codecs and Cloud Code. It works. Yeah. It's kind of in the same league, honestly, which is the model's credit, to the credit of, it's mostly a GLM, like ZAI's credit. But this thing works with that, and it didn't take me that long to do, so which is cool. And it being written in Nim, it uses a lot less tokens too to write stuff in Nim because it's so expressive. So the language model needs to generate fewer words for it to work, right? And it's like 4 megabytes. Yeah, that's really cool. Auto updates. Give it a try. Tell me what you think. All right. Thank you very much for listening. I hope this was interesting. And I'll see you next time. Bye-bye.